Alright, in this video we're going to talk about Unit 1, Objective 5, trapezoidal sums. Trapezoidal sums are an alternative to the Riemann sums that we found before to estimate the integral. With Riemann sums we found a finite number of rectangles. I'm going to blow your mind here, but with trapezoidal sums we're going to find the sum of a finite number of trapezoids. And that's going to be called the trapezoidal sum. Now, there are different ways other than Riemann sums and trapezoidal sums to estimate the area under a curve. But as far as AP is concerned, trapezoidal rule and Riemann sums are really the only way that we're going to deal with this. And then if we're going to figure this out, if we're going to find a bunch of areas of trapezoids, we need to know the area trapezoid formula, and that is 1/2 the sum of the bases, so base 1 plus base 2 times the height. Now, note that when we were in, or not necessarily when we were in geometry, but if we're talking about the bases of a trapezoid, those are the sides that are going to be parallel to each other. These in geometry tended to be the top and the bottom of a figure, right? If you think of a trapezoid, generally you're going to think of something like this, where the bases are the top and the bottom, they're the ones that are parallel. But in calculus, they're always going to be vertical sides. If you look in the picture, we have 4 different trapezoids, and you can see that the bases are actually going to be the vertical ones, right? In this first purple one, those are the parallel sides, those are the bases. So when we're thinking about base 1 and base 2 in the height, we want to think about the bases are actually going to be y values. And the heights are actually going to be the change in the x values. So unlike the Riemann sums where we had the base of the rectangle was the change in the x and the height was the y value, the bases for the trapezoidal rule are actually going to be our y values. So let's take a look at an example. Find, or estimate rather, the integral from 1 to 2 of x squared dx using a trapezoidal sum with 4 subintervals. So to kind of picture what we're dealing with, let's just do a rough sketch real quick of what we're dealing with here. So we're going to have x squared, but we're only going to be dealing with from 1 to 2. So we want to think about this area here. Now we want to split that into 4 separate trapezoids. So we're going to separate it there, there, and there. So we're going to be at 1.25, 1.5, 1.75. And if you think let me switch to a different color here. If you look at it, we're going to make these trapezoids here. Right, so we're going to have one trapezoid here, our second trapezoid here, our third trapezoid here, and our fourth trapezoid here. Now, most of the time, just like with Riemann sums, if you're given a problem where you're trying to find a trapezoidal sum, you're going to be given a table. So let's go ahead and make our own table. So we're going to say x values, f of x, or y values, and we're going to start our area at 1. 1 squared is 1. We're going to go to 1.25, and I've already done the calculation for you. It's going to be 1.563. Remember, in calculus, we want to go to 3 decimal places. 1.5, we're going to get 2.25. 1.75, we're going to get 3.063. And 2, hopefully you can figure that one out. It's going to be 4. So what we want to do is we want to think about our 4 trapezoids that they're asking us to make, right? 4 subintervals. So this is our first trapezoid here in red. So this one right there. So if we're going to estimate the integral from 1 to 2 of x squared with respect to x, if we think about all 4 of these trapezoids, they're all going to follow the same form of 1/2 the sum of the bases times the height. All of them are going to have that. So they're all going to have this 1/2. So anytime you're dealing with a trapezoidal sum, I want you to go ahead and factor out that 1/2. So if we think about it now, for this first trapezoid, the bases, remember with a trapezoid, the bases are the vertical ones, or the y values. So here are the bases. We want to say the sum of the bases, so 1 plus 1.563 times the height. Remember now the height is going to be the change in the x values. So going from 1 to 1.25 is going to have a height of 0.25. Now if we think about the second one, it would be this little trapezoid here. So again, we would have this 1/2, but we factored that out. So we got to think about the sum of the bases. Well, again, we're talking about the vertical parts. So the vertical parts are my y values. So 1.563 plus 2.25 times the height's going to be the change in the x values. So going from 1.25 to 1.5 is going to be another 0.25. If we think about this third one, it's going to be this little trapezoid here. So again, the 1/2 has already been factored out. Let's go ahead and finish writing this down here. The sum of the bases, so we're going to have 2.25 plus 3.063 times the height, once again, is going to be 0.25. And for the last one, this last little trapezoid here, sum of the bases are going to be 3.063 plus 4 and a height of 0.25. And that's going to be our trapezoidal sum. Once again, we don't have to simplify, and we do have to show this addition. We don't want to write 2.563 here, even though we know we can multiply by 1. When AP asks for a trapezoidal sum, they want to see that you're doing the bases added together. So this would get us full credit on this problem here. If you wanted to simplify it, this would probably be a calculator question. You are free to throw everything into your calculator, but make sure you're doing everything correctly when this is good enough to get us our points. All right, we have one more example I want to look at, and then we'll stop with this video. So an observer measures the outside temperature at different times between noon and 5, as seen in the table below. Use a trapezoidal sum in the intervals indicated by the table to estimate the average temperature during the 5-hour period. Now, there's something that we need to think about when we're dealing with this problem here. And that's the fact that they told us the word average. They threw that word average out there. Average temperature. So that to me means one of two things. We either have average value or we have average rate of change. So this is either going to be an integral problem or it's going to be a slope problem. The way to tell is to look at the units. If the units of what they're asking for, so the average temperature, match the units that we start with, that means average value. So that's going to be an integral problem. So they really want us to find, we'll call this noon as 0. The integral of 1/5 minus 0 from 0 to 5 of f of t dt. And we're calling noon 0. If you follow the pattern 5, 4, 3, 2, 1, we'll call noon times 0. And that's pretty common to call the starting time times 0. So this is going to be approximately equal to, so we're going to start with this 1/5. All right, so 1/5. Then they want us to use trapezoids. So anytime trapezoids happen, we want to pull out the 1/2. And now let's start looking at our trapezoids. So our first trapezoid is going to go from here to here. So the sum of the bases is going to be 63 plus 65 times a height of from 0 to 1 is going to be 1, plus our second trapezoid, the bases are going to be 65 and 66, and again a height of 1. Our third trapezoid is going to be 66 and 70, again with the height of 1, and our last one's going to be 70 and 69, once again with the height of 1. And I made a mistake. I was working a little too quickly. If you look, we go 1, 1. This actually has a height of 2. So the one that's dealing with 66 and 70 actually has a height of 2. And AP will do that to you most of the time. They're not going to give you an even space all the way through, so you have to pay attention and don't make the mistake that I just did. So from 2 to 4 actually gives us a change in x, or a height of 2. So again, we could stop here. That is algebraically equivalent to the answer. Or if you really wanted to know what the average temperature was over that 5-hour time period, you could work all this stuff out. But if you want to do that, I'm going to leave that up to you. I'm going to go ahead and stop the video here. See you in the next one.